Hello! In this video, we're going to prove the following theorem. Well, hopefully. There is a unique real number x, such that for all real numbers y, xy plus x minus 4 is equal to 4y. Okay, now, I haven't done this proof yet, so let's start off with scratch work. Okay, so where should we start? Well, as you can imagine, if we had x equals 4, we would have 4y plus 4 minus 4 equals 4y. And it seems like that would be true for all real numbers y. So let's just consider x to be 4. How can we be sure that this is going to be unique? Well, I guess what we'll do is we'll suppose x1 and x2 also satisfy this statement. Okay, but this would be true for all real numbers y. So then we could take y and substitute it for x2 here, y substitute for x1. That might allow us to show x1 is equal to x2. Let's try that. And similarly, I'll take y to be x1 here. Okay, well now we see that we have x1, x2 in both of them. So if we were to solve for x1, x2 here, well, we'll just add 4, subtract x1, and we'll take this, plug it into here. Let's see, did I do that correctly? That, and plus x2. Okay, yeah, we're good. But now we see that the 4's will cancel out, and if we notice we have 4x2 plus x2 gives us 5x2. We can add the x1 to the other side. That gives us 5x1, dividing 5 on both sides gives us x1 is equal to x2. So it seems like we have a derivation to show that this theorem is actually true. So now, let's go into the proof. Okay, so to start out the proof, well, notice we're trying to prove there is a unique real number x that satisfies this. So let's start out with proving that there exists a real number x that satisfies this. So we'll start with existence. Well, to show that there exists a real number x such that this is true, we'll show that in particular that this is true for x equals 4. And our goal from here is to show that for all real numbers y, 4y plus 4 minus 4 is equal to 4y. Well, since we're trying to prove a statement about all real numbers, give me an arbitrary real number. I'll call it y. Now we know that 4y plus 4 minus 4 is equal to 4y. So given an arbitrary real number y, we have that this is true. Since y was arbitrary, this means for all real numbers y, this is true. So we have shown that this is true for the real number x. So there exists a real number x such that this is true. So this completes existence. Now let's move on to uniqueness. Now in the uniqueness portion, we're trying to show that there is only one real number x such that this is true. And to do so, we'll suppose that there are two real numbers such that this is true. Call them x1 and x2. The whole goal of uniqueness is to show that x1 is equal to x2. Now, since this is true for all real numbers y, it must be true for the real number x2. So we'll take everywhere we see a y and substitute it for x2. And similarly, since this is true for all real numbers y, it must be true in particular for the real number x1. So we'll take everywhere we see a y and replace it with x1. And if you recall from our scratch work, we took this equation and solved for x1, x2. And we took that result and substituted it into the other equation. So let's take this equation and solve for x1, x2. If we do that, we're going to get 4x1 minus x2 plus 4. So now, since x1, x2 is equal to this, we can take x1, x2 here and substitute it for this. And now, notice the left-hand side really just simplifies down to 5x1 minus x2. And the right-hand side is still 4x2. And then, adding x2 to the other side, we get 5x1 equals 5x2. And then dividing 5 on both sides, we get x1 equals x2. And this proves uniqueness, right? So let's put this all together. We found a real number which satisfies this statement, right? So that proves the uniqueness portion. How do we know that this real number is unique though? Well, we suppose that there are two real numbers that satisfy this statement. Well, we show that those two real numbers have to be equal. So there can only be one real number which satisfies this statement. Namely, 4 is actually the one which will satisfy it. And so we've proven exactly what we wanted to prove. So this completes the proof. And so yeah, that's pretty much it for this video.